All right, so we're going to be doing function blocks in the Siemens software. And as I was saying a minute ago before I had to restart the recording, was that there's two purposes. One is to organize your code. Right? If we were to look at this trainer that you guys are going to be using, there are what I'm going to call 6 distinct sections to this. All right, section 1 is this first conveyor belt right here. All right, so that would be your first distinct section. All right. Second one would be the little pusher mechanism that's right here in the bottom left corner. Then we have another conveyor belt, and another conveyor belt, and then another one of those pushers, and then another conveyor belt. All right. So there are, as far as I'm concerned, 6 distinct sections. And your goal is to have all 6 of those operating consecutively, or all at the exact same time, not consecutively, that's the one after the other, all at the exact same time. All right. So conveyor belt 1 can move the part from where you put it down here to up here without affecting anything else, because it's like, hey, this is all self-contained. I know there's a part waiting to be moved. I can move it up here to get it as close to ready as I can for the next stage, so that way when the next one's ready for it, I can push this thing onto it. All right. Same thing goes for the next station. This one can start pushing the block forward when it's time to do that. This one can move the block up to and start machining it, and then wait for this one. This one can move the block and machine it. This one can wait and push it. This one can push it just past it. All right. So they all are dependent on each other because 1 is waiting for 2 to tell it that it's ready. 2 is waiting for 3 to tell it it's ready. 3 is waiting for 4 to tell it it's ready. 4 is waiting for 5. 5 is waiting for 6. So there's this kind of chain reaction going on. As soon as 6 is like, hey, 5, I'm ready for a piece, 5 should load a piece onto 6. As soon as 5 is ready, it should tell 4 it's ready. And it's, back down the line. So we also want them all to do something with the part as soon as we're ready, so that way it moves on as quick as possible. Right? In the world of industry, time is money. Right? If we put one part on here and it took 30 seconds to go through the whole process, right? You're like, well, I'm making one part every 30 seconds. Well, if we can shrink that we're now outputting one part every 5 seconds because each station takes 6 seconds to do, we've now multiplied our output by 6 times just by making them all work independently of each other. So we have these 6 different sections. So you could use these function blocks purely as one for each section of code. So that way you don't have all of your code in one screen. So that when you're troubleshooting, you're like, I only care about the code that has to do with the first conveyor belt or the first pusher or whatever the case is. So you could organize your code like that. All right. However, that's not the real purpose of function blocks. The real purpose of function blocks is to be able to reuse your code multiple times, right? So that way you can write it once and it can do the same thing 5, 6, 8 times that you have the purpose for that. So if you had 12 of the exact same assembly line lined up and you had little sections like this, you could use the same function block code for the first 6 sections on all of them. You wouldn't have to rewrite it 6 times and change all the inputs and everything. You could write your code once and just say, hey, here's the inputs for the first, conveyor 1 is section 1. Here's the inputs for conveyor 2, section 1. Here's 3, section 1. Here's 4, section 1. Here's 5, section 1. And that means when there's a problem, when you find out there's like, oh, we should have used sensor B instead of C or whatever the case is. All you have to do is change your code in one location, and it updates your code everywhere. Now, sometimes that's a good thing, and sometimes that's not, because if they're running ever so slightly differently, you're like, oh, we need to add a sensor on this one because it runs slower. Why? We don't know why the motor runs slower. It just does. All right. Well, that means now your code is kind of screwy between all these things. So it's not a perfect solution. But when you have 5 or 6 of the exact same thing and everything's working correctly, these function blocks are great. All right. Now, for this assignment of programming this thing, technically speaking, there are 2 sections that are duplicated. We have the pusher mechanism here and here. They are exactly the same. They have 2 outputs, they have 2 inputs. Their job is to do the exact same thing. Right? The other sections that are darn close, but not perfectly duplicated, and this is the fun part here, is this section and this section. All right? Those are the other 2 that are close but not perfect. And the only difference between them is how long we want to run the timer for. I want this station to run for 2 seconds, and I want this station to run for 1 second. So it's close, but it's not perfect. The other issue with at least function blocks in the world of Siemens is timers in them, you can't use multiple times. So if you have a timer inside your function block, it's the same timer being used in every instance, which screws things up. All right, so timers in function blocks get a little questionable, I'll call it at best. So, but anyway, let's go ahead and dive on into this. All right. So, how do we create a function block? Well, over here on the left-hand side, we normally have our main code. That's where we put all of our other code. Right? So we're just going to do add new block. Right? And we have talked a little bit about these different blocks before. Right? But we care about this time is the function block option. Right? And you can give it a name. So like if we're going to program the pusher mechanism, all right, I'm just going to call this pusher. All right, I'm going to go ahead and hit OK. And you will notice over here we now have a new function block called pusher. And up here it also does tell you that we are inside pusher right now. Right? This is one of those things that you do have to kind of start keeping straight now that you have multiple of these blocks, multiple different sections of code. Which one am I modifying? Am I modifying the pusher one? Am I modifying pusher two because I did program them separately and I'm not dealing with the proper use of functions? I'm using it for organizational purposes. What is going on? All right. So you do have to be kind of careful about which code we're editing, things like that now. So again, also down here at the bottom, you can see we've got our main and we've got our pusher. Right. Now the other thing about this is I've created this pusher block. It will not run until I put it in the main block. All right. So I could have all this code written. I could have 100 lines in there. And if I forget to put it in the main block, I forget to call it, which means to say, hey, go over here and run that code. It's not going to do anything. It's just going to sit there idle. Be like, okay, I'm here. What am I supposed to do? Right. So we do have to call that. And it is simple as grabbing our question mark block that you all know I love. All right, and then we just type in the name of the function block we're going to call, which is just pusher. Now in this instance, we're going to create a data block for it, which is great. And you can just see it just says EN and ENO. All right, so nothing going on there. We're about to change that. Okay. Now, we have to think of these as, if we're going to use them as their true purpose of multi-purposing them, we need to program without referencing actual tags. Now you're all going, what are you talking about? How do we program without referencing actual tags? Well, we need to create temporary tags. Right? And we do that at the top. I've showed some of you this just recently for storing your variables. All right, but we've got those double arrows there, little triangles pointing up and down. All right, and once we click on that, you can now see we've got a little bit more options than when we did a few minutes ago. We've got input, we've got output, we've got in, out, we've got static, temp, and constant. All right, so all of these are different tags. And these are all what I'm going to call temporary tags, even though there's one specifically called temp. Okay. But to me, these are all tags that only exist inside this function. Right? These are basically like you making memory tags, but you not having to say this is the specific location of said memory tag. All right? It will do that kind of for you in the long run. It doesn't really affect us at this point, what it comes down to. All right? But I already told you, remember how many inputs we have for this little pusher mechanism? Anybody? Told you that there were two limit switches, and then there's two outputs, one for forward conveyor, one for backwards, or forward pusher, backwards pusher. Right? So I'm going to make a tag here that's called back limit, or sorry, get that right, limit back, right? Because I like to put what it is first. And I'm going to make a limit front. All right, and then for my output here, I'm going to make a motor forward and motor reverse. All right, beautiful. I've just created those. Now, you probably are going to need more inputs. You're going to need like a signal, like, well, when should I go forward? And sadly, this is one of those things that the conveyor mechanism that we're going to be using, or conveyor, the trainer here is missing. There's no sensor that tells you there is a part in this location. You are actually relying on the previous conveyor to tell you, hey, I've put a part onto you. There's no sensor there. This one actually bothers me. One of those locations, there should be a sensor. Now, this could have been done for two reasons. One, cost. They didn't feel like putting a little sensor in there. All right. Two, probably the bigger reason, they ran out of I/O capability. All right. They used a 26-pin header to go from this board to our interface boards. All right. We use basically every single one of those pins on this assignment. Right? So my guess is they were like, well, we don't have enough inputs to put one in here, so we're just not going to be able to do it. Which, unluckily, is a legitimate reason not to put something, because you don't have the capability to handle it. Right? So we don't have a sensor, right here. So we have to actually rely on this conveyor telling us, hey, there's a part on there. So I'm going to add that actually. I'm going to add another input for start. I'm just going to call it start. All right. So we're going to do something really simple here. We're just going to do a quick little latching circuit. Start. These are normally closed, so I'm going to do that. Branch around my start button. There we go. So I've got start. And if you notice, this has a pound sign in front of it. That's telling you that it's a temporary variable, basically only available here. All right. My stop button is going to be my limit front. And I'm going to go with motor forward. And again, the one with the pound. And then down here, we're going to use motor forward as well. So if you notice, I haven't used any actual tags in here. All right, I have no clue why that one's yellow, right? Just so I'll have to look at that in a little bit. So I have no actual tags here. Right? But simple enough code, right? We press the start button, it'll turn the motor on as long as limit forward's not pressed. It'll go forward until we hit limit forward, and then it will stop. Simple enough code. Now, if we come back to our main, all right, notice this is now red. This is red because it's like, hey, you've changed things. We got to fix this. So if we right click on this, there is a update block call button right there. All right, I can click on that, and now you're going to see, going to go, hey, here's the old one, here's the new one. I'm going to go, okay, that's fine. Put the new one in. All right, and now it's like, hey, I need information. What should I use for all of these inputs and outputs that you have created? Okay. So for like limit back here, hopefully you have that actual limit switch tied to an input. Right? I don't have those in here. So let me go ahead and make those. All right, so we've got the tags. All right, and I'm just creating the tags that I kind of need. I actually create too many because of my simple. But we just created all the tags for both pushers here. Is what we did. So you can see our inputs. We've got forward, back, pusher 1, and pusher 2. So we've got 4 inputs there. We also have motor forward and reverse for pusher 1 and pusher 2. And then I have a start button for each one, so that way we can, again, make the thing start happening. Right. So if we come back to main, I can now fill in these blocks. So this would be limit back, pusher 1. This would be limit forward, pusher 1. And then this would be start, pusher 1. Over here, I have motor forward pusher 1, and I have motor forward pusher, reverse pusher 1. So there we go. So if we were to run this right now, we're basically just giving these things aliases. So now internally, inside this function box, anytime you see limit forward, it's now actually saying, oh, that's limit forward pusher 1. All right, so it's taking that tag, taking that information from it, and putting it in here. So it's a very easy way to be passing this information through. And as I said, the real benefit here is, since both of these are exactly the same, I can now create a second, if I spell this right, a second one of these. And I can now go with limit back, limit back. Can't spell limit, that's why. Below. Limit back, limit forward, pusher 2, start, pusher 2, motor forward, pusher 2, motor. There we go. Boom, there. So I only have one set of code. I'm calling that set of code twice, and it's doing it for both of these pusher mechanisms. So if I actually ran this right now, both of them would work perfectly independent of each other. Okay. So this can save you a lot of hassle of having to recopy your code. All right? Now, you might be looking at your code and you're like, Greg, that's one line. Why would I not just hard code this? Perfectly understandable. Not going to argue that statement. But when you start getting into like stages with things, and you're like, well, I've got 12 stages on this, this little conveyor belt, and I'm doing it twice, like the other one. We've got, moving the part from when we're told to load it to the milling machine, from milling it, moving it out of the milling machine, waiting for the next one, whatever the case is. You can see how that can kind of start growing and growing exponentially. That you can start having a lot of different code going on each of these little pieces. Now, all of ours are pretty simple because we only have so many inputs on these things. So it's kind of nice in that aspect. But it's really still a nice way just to keep all of your code organized. Again, even if you just say, all right, I'm just going to put all my pusher one code in the pusher block, and I'll make my milling machine in one, and my drill press in one, and my unloader in one, and my loader in one, however you want to do it, that's fine. It organizes everything, so when you're troubleshooting one specific section, you can go look at only the code for that one section. So it is definitely a bit of a give and take of what's the best. Can you use your tags directly inside of these function blocks? Yes, you can. You can hard code those in. All right. So if I come back into this pusher mechanism, I could add in here limit pusher one. What was this front? Limit pusher limit 4. There we go. I can put that in. I can hard code that in there. Every function block that calls this is going to use that. All right. So, like if you had an e-stop button, that would be a great place to put it. You could just pop your e-stop in there, say if this button's pressed, nothing's allowed to happen. And again, that's hard-coded in everything. It doesn't matter which conveyor it is. If I hit this e-stop, I want everything to stop in this facility. So hard-coding that inside these functions, perfectly fine. If you're using them just for organizational purposes, everything's going to be hard-coded here. Perfectly fine. Right? But I say, try to use these how they're actually supposed to be used. Now, as I did say, there is no good way to do timers in here because everyone calls the same timer block, which to me is absolutely annoying. I did some Googling to find out if there was something I was just missing, and the answer is no. You can't just directly put a timer, pass a timer in. You can't be like, oh, I want to pass this whole system block into this thing, and have, I want to pass timer 1 in the first time I call it, and timer 2 in the second time I call it. Because again, these two middle ones are exactly the same. The same number of motors, same number of sensors, everything. It's just one is going to run for 2 seconds, one's going to run for 1 second. Even if they both ran for 1 second, we couldn't do it because they're both using the same timer. So unless they time them at the exact same time, there has to be a block under both of them before we can do anything. It's not going to work because, well, what happens if the assembly line gets slowed down, all of a sudden the back is empty? Well, now you're waiting for something to get to the next one, it never comes. So we can't. Now you can get around that. You can cheat the system. All right, and I have my simple way about cheating the system. I'm going to call it timer in, and I'm going to add another one down here. That's timer out. Or I don't want to name it. I need to reverse these. Timer out is an input. That makes no sense, right? Not. Timer in. Right. So, but what we can do is in our main code, I say we had to update these now because I changed them. And this is my hackery. This is not like a supported system. All right. But this is my hackery. But what we can do here is we can a ton. Fine, and throw an output here. So this would be, need to make a memory bit for this. Oh, let's call it M3.2. Or there we go. Make this M3.4 or 3.3. Get the period in there. And this will be what is this? Milling. Oh, sorry, I did that wrong. Name this. So, to use a timer, there's really only 2 things that we really need, right? We need to be able to put the timer on. We need to know when the timer's done. Right? So we can cheat that system here And so my timer out, I can do milling timer out here. And I can do my milling timer in here. So now we can pass that information in. We can say, hey, the logic inside the function block wants to make the timer count. Right? And that's what we're doing. We're saying, hey, when the timer input turns true, make the timer count. And then when we say, hey, when the timer's done counting, turn this output, this true. All right? So we can use these timers outside of the function block with just two other tags. All right? So is this complete hackery? Oh, you better believe it. All right? This is a way to get around the, like, I need a timer, but I can't put it in the function block. There's probably a better way to do this, but this will work. So you can pass that information in and out of that timer as you deem necessary to what it comes down to. So you could say, like, hey, when the conveyor's off and there's a part at this sensor, turn the timer on, like make the timer count. Right? And that's where milling timer out would go. All right? And then you're like, hey, when the timer's done counting, tell me via milling timer in. We pass that in, and that's like, hey, turn the conveyor on, and then everything works. Right? So this will work, but it is definitely a workaround for a solution that Siemens should come up with a solution. But I don't think they're going to do it because I think some of these threads that I looked at are kind of old at this point, from 2012. All right, so I think that technically the PLCs we're using are actually out of date. They're not officially being used, discontinued, so it's still a PLC. It still works, but Siemens like we've moved on to better pastures. So anyway, so that is our function blocks in a nutshell. Okay? You can use them for organization. Just put all your stuff related to different sections inside the code, hard code all your inputs and output values, right? And that will be fine. Just make sure you call it from the function, the main block. Or you can use them how they're supposed to be used and write code in there using variables that you then feed inputs and outputs to. So that way you can make your decisions based on these things. Questions, comments, issues, concerns for me? Not right now. Awesome. All right. So I guess at this point it's time for you to go ahead and try your hand at these function blocks, at least when you get to the conveyor belt stuff.